How good is a Taylor series approximation? Well, we can use the error to find out. Let's write down the error. So f of x, here's the Taylor series formula, f of 0 plus f prime of 0 times x, all the way up to the nth derivative of f at 0 over n factorial times x to the n, plus, here's the error, r sub n of x. So this is the approximation, and this, that's the leftover piece, that's the error. Okay, so what makes the error small? So near the center, which here is 0, the polynomial and the function line up well, but further away they drift apart, and that drifting is the remainder. So here's the formula, r sub n of x, the remainder, is less than or equal to big M over n plus 1 factorial, absolute value of x to the n plus 1 power. So m is any number bigger than the n plus 1 derivative on the interval between 0, because that's what we're centered around, and x. So the formula gives a safe upper limit for the error. Here's an example. If we say e to the x is approximately 1 plus x squared over 2, well then, so derivatives of e to the x are all e to the x. And near 0, e to the x is less than or equal to e. So let m equal e. Okay, so this works for small x, like absolute value of x is less than or equal to 1. So plugging that into the formula, r sub 2, because we're using the second derivative right here, we're just using this formula, plugging everything in, less than or equal to e over 3 factorial absolute value of x cubed, which equals e over 6 absolute value of x cubed. So the difference between the true value and the polynomial is at most this right here, e over 6 times absolute value of x cubed. Smaller x means smaller error, and more terms means more accuracy. So we can use the remainder as a bound to see how good the approximation really is. Okay, hope that helps. Thanks for watching.